Hello everyone. Today I'm going to start complex numbers, the first series. I'm going to upload multiple videos for JEE mains and engineering entrance exams in maths and physics. And I'll be explaining concepts and all the details related to that and PYQs and also complex problems that make you easy to understand. Now let us now start complex numbers, the first part. So what is a complex number? So So let us start complex number. Say I have an equation like x square plus 1 equal to 0. Now, in order to find the roots of this equation, so I'll say now x square equal to minus 1. So which will be x is equal to root of minus 2. Now, if you see, this is not a real number. This is an imaginary number because we cannot find square root of negative numbers. So those are not real numbers. This will be an imaginary number. And this will be represented by I. I is an imaginary. Now, complex numbers are combination of real numbers, of real and imaginary numbers. Complex numbers are combination of real and imaginary numbers. Say, now I have z is equal to x plus iy. Okay, because z is always represented as a complex number, and here x is the real part, and y is the imaginary part. Imaginary part. That means if I say RE of Z, I'll get X, and IM of Z, I'll get Y. So anything, if you see here, anything associated with I is a imaginary number. If you say I is an imaginary number, and what is the value of I? I is equal to square root of minus 1. That will be represented I is equal to square root of minus 1. Then what will be I square? I square will be minus 1 whole power 1 by 2 whole square. Now 2 gets cancelled, you will get minus 1. Okay. Now what will be I cube now? I cube will be I square into I. So which will be minus 1 into I, which will be minus I. Then what will be I power 4? I square whole square. So which will be minus 1 whole square, which will be 1. Because minus of even any to the power of even number, power of even number will be positive always. Okay, so this is how we represent a complex number is expressed in a form of a real part plus imaginary part. And if I want real part of complex number, that will be the saying, if you have z equal to x plus iy, real part of a complex number is x and imaginary part of a complex number is y. Now for this complex number to be, for this so now z is equal to x plus iy, x plus iy. Now for this complex number, for complex number, for complex number to be pure real, for complex number to be pure real. So when I say pure real, so that means the imaginary part should be 0. Okay, so y equal to 0. That means the imaginary part, there should not be any imaginary part. There should not be imaginary part, then it will be pure real. Then at the time z is equal to x, because I into 0 will be 0. Okay, for complex number to be pure imaginary, for complex number, for complex number to be pure imaginary, imaginary. So what will be then? So it should be x equal to 0. X. Okay, this is x. This is the real part, x. X equal to 0, or I'll just, so this is x equal to 0. Okay. So x equal to 0. So that means z is equal to 0 plus iy, which will be iy. So which is your pure imaginary part. Okay. Now let us now solve one problem. So as we do many problems, so we'll understand more concepts and more practice also. Instead of just learning the concepts and leaving it like that, so we have to do many problems, not only simple problems, even complex problems also. Now let us now solve one problem now. So I have now I power 400 plus I power 398 plus I power 396 plus I power 394 plus I power 392 whole divided by I power 392 plus I power 390 plus I power 388 plus I power 386 plus I power 384 plus 5. Now I have a problem like this. Now what will happen is, now you see here. See, don't get scared by seeing this problem. Okay. So see, whatever the concept I told you just a few minutes back, we can apply that concept and do. What is I root of minus? What is I square minus? Like that. Now, if you see here, now take the numerator power of I. Take the numerator power of I. 400. Do term by term. So what is the denominator power? 392. Now 400 minus 390 is how much? 8. If you see in every case like this, say, now here also you see 398 here. That means the second term of the numerator power, the second term of the denominator power, 390. So it will be now 398 minus 390. How much? 8. Now if you see, there is a common difference among all this. Now what you do now? Very simple now. Take in the numerator, see the common difference, the power difference is 8. Now take I power 8 as common. I power 8 as common. Now if I take I power 8 as common, now what will be remaining here? I power 392, because out of 400, if I take 8 outside, 400 minus 8, 392. Plus here, if I take I power 8 outside, what will be remaining here? I power 390. So here it will be 388. Here it will be 386. Here it will be 384 whole divided by, okay, the denominator is like this one, right? I power 392 plus I power 390 plus I power 388 plus I power 386 plus I power 384 plus 5. Now numerator and denominator gets cancelled. Now you see your life becomes very simple now. I power 8 plus 5. I power 8 plus 5. I power 8 is how much? I square whole power 4 plus 5. But what is I square? I square is, always try to simplify. If you have huge power of, large power of I, try to make to power 2, power 3, power 1. Okay? It will be very easy for you. I square means minus 1 whole power 4 plus 5. But what is minus 1 to the power 4 plus 4? I mean whole power 4. Anything to the even power is even, right? So it will be now 1 plus 5. It will be 6. That's all. See, once you see, by seeing the problem, you might see that how much. See, now we have done in 2 steps. In 2 steps now, this is now power 6. Okay. Now we can solve a similar problem. Just take down this. Okay. Now if you can start, you can pause the video for some time and you can note down also. Okay. Now take down another problem now. Now find value of I power 250 plus I power 248 plus I power 246 plus I power 244 whole divided by I power 244 plus I power 242 plus I power 240 plus I power 238 minus 1. Just to see like earlier problem. Okay, take the common power of the first term of the, take the power of the first term of the numerator and take the power of the first term of the denominator. How much you subtract? 250 minus 244. It will be 6. I think in other terms also same. Corresponding terms also will get same. So now take I power 6 as common. Now it will be I power 244 plus I power 242 plus I power 240 plus I power 238 whole divided by I power 244, I power 242 plus I power 240 plus I power 238 minus 1. Now numerator denominator gets cancelled. Now we'll have I power 6 minus 1. I power 6 means again I can write as I square whole cube. Okay, 2 into 3, 6, right? Minus 1. So minus 1 whole cube minus 1, which will be minus 1 whole cube minus 1 is minus 1 only, right? Because you need the odd power, anything to the power odd, minus to the power odd will be minus only. So minus 1, which will be minus 2. Okay, take down this. Now, now, now let us see now algebraic operations in a complex number. Algebraic. That is algebraic. When I say algebraic, additions, multiplications, all that. Algebraic operations. Okay. Now say, now I have two complex numbers. Say one is x plus iy. Another complex number is a plus ib. Now I want to add these two complex addition. So how to add? Very simple. Take only take the real numbers and add, and take the imaginary numbers and add. That means take real numbers as one group and add it. So it will be now x plus a. Take the imaginary numbers and add it, y plus b. That's all. So again, this is one complex number. See, again, this is one complex number. Okay. Example, if you see 2 plus i3 plus 5 plus i6. So it will be now 2 plus 5 plus I into 3 plus 6. So it will be 7 plus I9. Okay, that's all. Now similarly, subtractions also. So x plus iy minus a plus ib. So what you'll do? So I'll do now x minus a plus I into y minus b. That's all. Next is multiplication. So x plus iy into a plus ib. How much now? You see. Now take this ax plus take this I B X. Use a distributive property. Okay. Next take this plus I A Y plus take this I square Y B. Now it is a distributive property. Okay. How you multiply two expressions. Now it will be now AX. Okay. Now bring all the real terms to one side. I square is how much? Minus 1, right? So it will be minus YB plus here these two take I common. Now it will be BX plus AY. Okay, that's all. So any complex number has to be expressed in the form of real plus imaginary. So this is the real part and this is the imaginary part. Now let us see the division part. So now I have now x plus iy by a plus ib. Now, if I have division of two complex numbers, always rationalize this. Rationalize. So when I say rationalize, how I'll do? X plus iy by a plus ib, I can write it as x plus iy into, see, both numerator and denominator, what you have to do? You have to multiply. See, a plus ib means here a minus ib. Again here a minus ib. The thing is, if I cancel these two, again I'll get the same. But why I'm doing this is because your denominator should form a real number so that you can express this in the form of p plus iq or a plus ib or x plus iy, like that. Why actually, how the denominator will form a real, a real part, I'll tell you here. See, this is in the form of, this is in the form of a plus ib into a minus b. We know in algebra, a plus b into a minus b is equal to a square minus b square, right? The same thing I'm doing here. So a square minus I square b square, a square minus I square b square. Okay. Now this will be now ax minus ibx plus iay minus I square by. So this will be now a square minus I square will be, it will be minus I square will be minus 1, right? Sorry, I square will be minus 1. Minus of minus will be plus. So plus b square. Now you bring the, like again here, minus I square will be plus 1. So now it will be ax plus by, okay, plus I into ay minus bx. Now I will bring the real numbers to this set. See, ax plus by a square plus b square plus I into ay minus bx by a square plus b square. Okay, now you see here. Now this entire thing I can make it as p. I can think as p. And this entire thing I can think as q. Now this is in the form of p plus iq. P plus iq. This is how I will bring into this form. That's why whenever we have divisions, always rationalize. If you have division of two complex numbers, always rationalize. Okay. Now let us see one example. Now I have find value of 1 plus I by 1 minus I whole square plus 1 minus I by 1 plus I whole square. Okay. This, how I can do this, in the form of, see, a square, see, 1 plus I plus, so how I can do, see, this is one complex number division, this is another complex number division. So what I will do, first rationalize this, 1 plus I into 1 plus I by 1 minus I into 1 plus I. See, if I have a complex number division like this, a plus ib into x minus iy. So always x minus iy you have to keep denominator, but you have to multiply numerator and denominator with plus here, because already my original is x minus iy. Now I have to divide the numerator, you have to multiply and numerator and denominator with x plus iy. This will be a plus ib into x plus iy. Okay, same here also. If I have 1 minus a, here I have to both numerator and denominator with 1 plus I. So again, this is whole square plus 1 minus I into 1 minus I by 1 plus I into 1 minus I whole square. So this is equal to 1. This is in the form of a minus b into a plus b, which is nothing but a square minus b square. So 1 square minus I square. So again, this will be 1 plus I whole square. Again, you multiply this. This is to the power of 2. So plus, this will be 1 minus I whole square. This will be 1 minus I square whole square. Okay. Now, this will be what? Now, expand this. This is in the form of a plus b whole square form. A square plus b square plus 2ab. This will be 1 plus 1, because minus I square. I square is minus 1. Minus I square will be plus 1. Minus of minus. Plus 1 plus I square minus 2i by 1 plus 1. Okay, so this is whole square. This is whole square. So this will be how much? I square is minus 1. Minus 1 minus plus 1 is 0. 2i by 2 whole square plus minus 2a by 2 whole square. So 2 cancel. 2 cancel. Now I'll get I square plus minus I square is also I square only. Okay. What is I square? Minus 1, minus 1, minus 2. This is answer. So minus 2 is the answer. Just see. So just see how I'm solving. So first I'm simplifying this part and next this part, and then what I mean by simplification is divide. I mean like multiply and numerator and denominator with the with what actually my denominator is 1 minus I. So you have to multiply numerator and denominator with 1 plus I so that your denominator becomes the real number, because it is in the form of a square minus b square. Always I square will be minus 1. Okay. So we'll stop now. Okay, then I'll upload the another set of complex number series. And thanks for actually watching this video. And please subscribe to this channel, Xrise channel. And as I told, actually, I also have a website, www.xrise.in. You can actually log into this website. You can register here. It is a free registration, and you can attend mock exams. I'll be uploading mock exams also in this. And going forward, I'm going to upload all conceptual videos, even PYQ solutions, how we can solve PYQs in all topics of maths and physics. Okay. Thank you, everyone.